Yesterday we did difference of squares. So it was a subtraction problem and we had two perfect squares. Today we're going to do sum and difference of cubes. So there is no sum of squares. There's only a difference. It only works if there's subtraction. But if we have two perfect cubes, we have a formula for when there's a plus sign between them and a formula for when there is a minus sign between them. So I want you to go ahead and fill in these first perfect cubes. Now, 1 is also a perfect cube. 1 times 1 times 1 is 1. So I didn't put that one on there. But go ahead and fill those out. So we have 8, 27, 64, 125, 216, 343, 512, 729, and 1000. A quick way to get those without having to type them all in is I went to y equals and I put in x cubed and I looked at my table and it told me what all of those were cubed. So that was a quick, easy way to get that list. To be a perfect cube, the exponent must be divisible. Any guesses? By 3, yes. So a perfect square, it's got to be divisible by 2. To be a perfect cube, it needs to be divisible by 3, and that pattern would continue. So to be a perfect cube, the exponent must be divisible by 3. So when we're taking the cube root, as we can see here on the side, you divide the exponent by 3. That's how you find the cubed root of a variable. So the cubed root of x cubed would be x to the first, or just x. The cubed root of x to the 9th would be x cubed. What about the cubed root of x to the 30th? Yep, x to the 10th. What about x to the 42nd? X to the 14th. X to the 60th. X to the 20th. And x to the 300th would be x to the 100th power. So divide it by 3. Here is the rule for sum of cubes. Now the sum and difference of cubes, the formula is almost identical. The only differences are the pluses and minuses, and you'll see that. But we're only going to do pluses right here. So if we have a cubed plus b cubed. So we have two perfect cubes with a plus sign between them. It's a plus b. And then in the other parentheses, it's a squared minus ab plus b squared. So example number 9. We first need to identify the a and the b. So my a is the cubed root of x cubed. So it's the cubed root. Now we're not doing square root. We're doing the cubed root of this first term. And so what is this? X. And b is the cubed root of 27, which is look over here at your list. Here's 27. The cubed root would be 3. Now the formula also calls for a squared. So if my a is x, what would my a squared be? x squared. And then it also calls for AB, which would be my A times B. What would that be? 3x. And it calls for B squared. So 3 squared would be 9. And let's see. We've got A plus B, so x plus 3. And then my A squared, which is x squared, minus AB, which is 3x, plus B squared, which is 9. When you're working these problems out, I definitely want to see this work. I want to see your A and B. If you can do this part in your head, I'm okay with that. But at least starting out, you probably want to write this out. So A is the cubed root of 125. What is the cubed root of 125? 5. If you don't know how to do the cubed root in your calculator, if you go to math, number 4 is the cubed root, or number 5 lets you type in whatever root you want. Like that. But since we have this list here on the side, you really don't need to type those in. So you can see them here. B is the cubed root of x cubed, which is x. So what is my A squared? Do what? 25. If my A is 5, 5 squared is 25. Then AB, if you multiply those, you get 5x. And B squared would be x squared. And now it's just a matter of filling in to the formula. 5 plus x, 25 minus 5x plus x squared. Remember, we are supposed to be looking for GCFs in these. I haven't really been doing that because I know these first two don't have one. Questions? Number 11. There's no GCF because those letters are different. So A is the cube root of my first term. So the cube root of x cubed is x. B is the cube root of 216 y cubed. So we have numbers and variables. Take the cubed root of them separately. So this would be 6y. The cubed root of 216 is 6. And then the cubed root of y cubed is y. A squared would be x squared. What would AB be? 6xy. And then what about b squared? 36y squared. You got to square both of them. 6 squared is 36, and then y squared. And then that goes in x plus 6y. X squared minus 6xy plus 36y squared. If you wanted to check your answer, you could plug in a number for x and a number for y, type that into your original problem, and type that into your answer and see if they match. And if they do, then you're pretty sure you got the right answer. Number 11, is there a GCF? What can you divide 8 and 64 by? 8. And they do not both have the same variable, so only an 8. X to the 9th minus 8y to the 7th. So all I did was divided both of those by 8. Then my A is going to be the cube root of x to the 9th, which is x to the 3rd. Remember, we divide the exponent by 3. Oh, that's not 7. Why did I? Oh, I took the cube root. That should be 21. Y to the 21st. I was thinking ahead. Sorry.
Also, I have a question.
Yes.
How do we get the negative or the minus instead of the plus?
It's supposed to be a plus 2.
Sorry, I was.
No, thank you. I'm not with it this morning. Y'all need to call me out on my mistakes. All right, B is the cubed root of 8y to the 21st, which is what? What's the cubed root of 8? 2. And then what about y to the 21st? Y to the 7th. So what is my A squared? X, not x to the 9th, x to the 6th. Think about your exponent rules. If we do x cubed squared like that, you multiply your exponents. So it would be x to the 6th. AB, if we multiply these two, we get 2x cubed y to the 7th. And what about b squared? It would be 4, because 2 squared is 4, and then y to the 7th, when I square that, I get y to the 14th. These are the types when I've got like something like this is where you're probably going to make the most mistakes. So be very cautious. So then our answer, we have to bring down the GCF. That still has to be part of it. X cubed plus 2y to the 7th. And then we have x to the 6th minus 2x cubed y to the 7th plus 4y to the 14th. So once you have what I've got here in orange, all you're doing is plugging into the formula that I wrote at the top. So getting these is the hardest part. Any questions? Number 13 has a GCF. What is it? 4. So if I divide everything by 4, get 125x cubed plus 1. One of the biggest mistakes that a lot of you made on that Google form was that you were like, well, this 4, I took out the 4, and you left off this plus 1 at the end. When you divide by 4, it's not 0, it's 1. So A is the cubed root of 125x cubed. Which would be 5x, because the cubed root of 125 is 5, and the cubed root of x cubed is x. B is the cubed root of 1, which is 1. A squared. What do I get if I do 5x times 5x? 25x squared. Perfect. AB. 5x times 1 is just 5x. And b squared, 1 times 1 is 1. Don't forget your GCF when you write your answer. It's very easy to do. So we get 4, and then in the next set of parentheses is 5x plus 1, and then in the next set, 25x squared minus 5x plus 1. Questions? If there's one of these parts and you're like, I don't know where you got that, please speak up. Number 14, GCF. Does number 14 have a GCF? 4. Yep. We can divide all those by 4. Eight x cubed plus 125. So your A is the cube root of 8x cubed, which is 2x. B is the cube root of 125, which is 5. What is A squared?
4x squared.
Yep, 4x squared. 2x times 2x is 4x squared. What is my AB? 2x times 5 is 10x. And b squared is 25. If you bring down your GCF, 2x plus 5, 4x squared minus 10x plus 25. I feel like on all these we've used 8 and 125 on all of them. Number 15, is there a GCF? Well, there would have to be because 250 and 16 are not perfect cubes, so it is 2. And look, we have 125 x cubed plus 8 y to the 12th. See if you can finish number 15. All right, for A, you should have got 5x. B, 2y to the 4th. And then A squared would be 25x squared. Your AB is 10x y to the 4th. And your B squared is 4y to the 8th. Any questions over this part? And then you just fill that into the formula. Number 16, GCF.
3.
It is 3. Look at your variables. How many x's can you take from both of them? You can take one x, because this one doesn't have any more than one, so it can't take any more. And then what about y's? You can take one y. If you didn't do that, and then when you went to try to take the cubed root, you can't do 4 divided by 3 and get a whole number. So that would have been your hint that something's off there. And when we divide by 3, guess what we get? 8x cubed, another 8, plus, and another 125 y cubed. So my A is going to be 2x. B is going to be 5y. A squared is 4x squared. AB, 10xy. And B squared would be 25y squared. And then we put it all together. We have the 3xy in the front. 2x plus 5y. 4x squared minus 10xy plus 25y squared. Questions? Really quick, let's turn it over, and I'm just going to give you the formula for difference of cubes. And we might come back and do a few examples tomorrow. It's the way you solve it is identical. The only difference is one of your pluses and minuses is flip-flopped. So when you're subtracting, it's a minus b, a squared plus ab, and the last one is still plus. So it's one is minus plus plus, and the other one is plus minus plus. And then you do the same steps to solve it. So tomorrow we may do 1 or 2 examples, and then I've got a cut and paste puzzle for these that you're going to work on with a partner.